Our exploration of fundamentals in resilience engineering has revealed that there is a universal constraint, a universal property of all adaptive systems that operate at any and all scales. Viability requires extensibility. Resilience as extensibility is a critical property for systems to have to overcome the risk of brittleness, the risk of saturating the capability to respond as situations develop, grow, as challenges to the way you've been designed to work. So we want to, in this video, illustrate how resilience as extensibility can be seen in a very practical sense. And we're going to do this by looking at a real case. And in this real case, we're going to be able then to point to general patterns, right, about how this plays out so that we can think about the ways that we would architect and design systems to enhance their capability, right, to demonstrate graceful extensibility. So the question for resilience as extensibility is, how does the system handle the next challenge case that it's going to face, right? When that challenge case reveals inconsistencies and gaps in the plans and competencies. How does the system deploy, mobilize, and generate adaptive capacity to keep pace with the spreading challenges over time? Now, these ideas have long relevance to disaster response. It's where we've traditionally thought about these kinds of processes and the way we've studied them and tried to design systems to be more effective. As one expert in this several decades ago pointed out, Longadek said, covering how extensibility and challenge works, right? The challenge event can be considered a brutal and abrupt audit. If at a moment's notice everything that was left unprepared becomes a complex problem, and every weakness comes rushing to the forefront. So we don't want to be in that situation where we become overwhelmed, we become saturated, we become overloaded. That's what Longadek was pointing to, how easy is it for that to occur. So we're interested in beyond surge capacity events. We're based on a concrete case. This concrete case has several papers investigating a real mass casualty event in an emergency department. And we're going to look at this process of how we deploy, mobilize, and generate over time the extra adaptive capacity to keep pace with challenge. So as saturation approaches, how do we extend our capabilities, because we'll start to run out of deployable assets. As our deployable assets saturate, we will have to mobilize and inject capabilities, or even generate new capabilities that we could then inject into the situation. But timing matters a lot. We have to be able to put those into action before we saturate resources, capabilities, or expertise. So let's look at a beyond surge capacity event that really happened. We'll try to highlight the general patterns and rules that this illustrates, the challenges that are faced that Longadek indicated with that quote. So we're going to start with an emergency room, and we're going to draw some graphics to help us understand it. And those graphics have a y-axis. And that y-axis is some dimension we can use of the load on the system. So we can look at how well it can respond to that load, so we can capture when is it overloaded. And in an emergency department, we can think about that in terms of the number of patients. Oh, that's oversimplified because the severity of the injury, the different types of injuries or illnesses that come in can all affect load, especially with respect to the resources available to respond, the forms of specialized knowledge and expertise, the kinds of equipment and supplies and resources that can be needed to treat different kinds of patients. Different kinds of assets may be needed in diagnostic and imaging and other kinds of facilities in the hospital system. So load has a multidimensional quality, but we can simplify it and think about it in aggregate fashion. Now we can then plot that over, that load changes over time as people respond. right? Deploy, mobilize, generate is developing response capability to meet demands. So we want to see how extensibility plays out as a beyond surge capacity event begins. Because at the beginning, you don't know that it's a beyond surge capacity event. Okay, well, how am I going to score surge capacity? Well, first of all, that's what an emergency room is all about. It's got some ability to vary, have enough resources and capability to handle varying load. How much load can it handle? Well, there's a nominal amount of load given its resources in staff and space and equipment and expertise. How much can it handle? Well, in our case, we're going to say that's the nominal capacity, right? And that's sort of the textbook, what it's sort of resourced out at officially by the organization. And we're going to say that's 28 patients, right? Now, what's interesting, if we look at this chart of how the event began, notice how many patients are in the emergency room. 40 or 41. Wait a minute. That's more than its nominal capacity. Now notice there's another line here. In other words, it's handling more than its nominal, therefore its effective surge capacity is different. So the real organization has already developed, the work as done has already configured and prioritized in a variety of ways because it regularly experiences a kind of overload relative to nominal capacity. It's used to working at higher than nominal load. And that overload now isn't overload, isn't experienced as overload, it's just the load that we handle. Some days may be better than others, but we have the regular experience of operating above our nominal capacity, right? So we have an effective capacity that's higher. Now, wait a minute here, everybody. Think about how this applies to you in all forms of life and activity and systems you're in, right? Under others adapting to take advantage, keep pushing you back to the edge of the envelope. This is right? The law of stretch systems that predated the discovery of graceful extensibility. Go back to that video and look at the law of stretch systems. So we are all experienced operating above nominal, right? Of being kind of overloaded in a way that makes us feel it not as overload, but as normal load. Yes, there's variation. Some days are easier than others. Some periods are more peak. But in all of these cases, we have to adapt and develop adaptations in order to have a higher effective surge capacity. Right? And those adaptations linger around even on days that are easier, situations that are easier. So that's illustrated here in simply that 28 happens to be their nominal load for this emergency room in this actual event, and 55 turns out to be a good estimate of their effective capacity to handle patients. Again, they're contextualized on these other factors that make that dimension multidimensional. Now, what happens at the beginning of the beyond surge capacity event? Well, the people in it don't know it's beyond their surge capacity. They're used to having varying surge capacity, and they're used to doing things in order to avoid getting saturated, right? They anticipate approaching overload, anticipate approaching saturation. That's what we do in these situations generally. And so we have ways to reprioritize and reconfigure so that we don't run out of capability to respond. Now, we're facing uncertainty at the beginning. We don't know if this is just a few extra patients. Right? We don't know if this is the beginning of a much larger surge of patients coming our way. We may not know a lot. Are they all going to be like these patients who just arrived? These 5 or 6 patients who've just come in over the last few minutes? What does this represent ahead? Now, how would we know more about what is coming at us? We would have to have information from other parts of the system. Other roles at other layers would have to tell us more about what's coming in. But generally, in the emergency room context, you often get delayed information about what's coming at you. Now, let's move ahead in time. what really did happen, because we all know it's a beyond surge capacity event. It's going to go higher than 55. Right? And so now we look a little further in time and we can see that the number of patients who were in the emergency room before, or who are showing up in the regular flow of patients, are still running, right, about in the low 40s. We haven't been able to move anybody out yet, right? We still have to take care of them. Meanwhile, we're moving up into the 20s, into the 30s of patients, all coming from one event where they were all injured in one catastrophe. And they're all injured in the same way with surface burns. So we have to handle burn patients, which require specialized care and resources. Now we're operating well above our maximum effective surge capacity to handle patients. So what's going on now? We have to anticipate, what are we going to run out of? We're experiencing shortages already, shortfalls already. Do we have a lot of expertise on how to handle burns? Right? How do we reconfigure in order for the knowledge that we have about burn care in those first hours after injury? How should that be done? What are the physical assets, resources that are needed to treat these people? Right? Where do we get more of it? Because we're going to run out. Can we get it from inside the hospital? We have to reconfigure activities and relationships to handle this increasing load or this increasing shortfall of key resources. So how do we alert the players inside the system that we need these assets quickly? We need more expertise. Where can we find people who understand burn care? We have to reconfigure those sources of expertise because they're going to have to guide other people who aren't so knowledgeable in burn care because of the number of patients we have to deal with. Oh, wait a minute, we need to help get these patients out who are less severely injured but were already in the emergency room. Who can be moved to another part of the hospital? Who can be sent home so that we free capacity up ahead? What might we relax or sacrifice? For example, we would sacrifice some of the documentation, but you can't sacrifice all of the documentation because you have to hand off in the future the patient's care to other parties, right? And they need to know what and how you've been treated. You need to know what to sacrifice. For example, the procurement system might dictate through the computer a certain way that you request supplies and that there's a certain lag in when those supplies will occur. That lag is way too long for this situation you're in. You need to have a more responsive system that gets you key physical assets more quickly to meet the high demand, the high need that's there because the patients are injured and need care. So ultimately, the ED needs to avoid overload and running out, not simply in terms of what internally controls, not just stretching out to the hospital itself, but stretching out wider to say, how do I mobilize resources and capabilities? Now, one of the nice things that indicates that there is a effective, resilient culture, so to speak, and I mean that in a very so to speak kind of way, using the word culture. But what happens because it's a hospital in the first world? Once people hear about the mass casualty event that's driving this, what do the staff of this hospital do? They head to the hospital. They don't wait to be called. They don't wait to be signaled what specialty is needed. They come to the hospital to try to help. Now, what happens then? Now we can see that we have a variety of assets coming to bear. We're trying to coordinate within the ER to the hospital to other hospitals, because as you start to run out of some of the supplies to treat burns in the hospital, so you run out real quick in the ER, Then you need it from the hospital, you're going to need it from some other places. Oh, guess what? The mass casualty event is big enough that multiple hospitals are overloaded with burn patients. So everybody is trying to get additional assets from other places who also need those assets. So which places aren't using that asset for treating burn patients to get them to the multiple hospitals that need to treat burn patients, right? This oversubscription of backup resources is very common in these events, right? We all count on these resources, right, in our contingency plans for emergency operations. What happens, right, as the scale of events grows, and that tends to happen with growth and complexification, as well as the changing forms of challenge that can occur from external sources, right, all of a sudden what happens, right? The thing I thought I could get people from, supplies from, whatever from, you know, the backup software, backup this or that, all tend to be grabbed by various parties competing. It becomes oversubscribed and therefore underserves the various contingency plans, meaning you fall behind, you saturate. When you saturate, there's forms of brittle collapse. There is harm, right? In this case, very tangible harm and less than ideal care for injured people. Now, in order to handle this high load and start to get it to go down, I've got to mobilize resources and capabilities to cope with overload before I saturate. Right? I have to synchronize with other players, right, in the ER, expanding the ER's capabilities, right, and synchronize with other parts of the hospital. I have to synchronize with other hospitals. Right? I may have to synchronize with other authorities, and depending on the scale of the disaster this represents, this is a piece of. Now, mobilizing resources means I have to put them into action. I have to make them deployable. I have to bring them in to have an effect relative to the demands. Right? So I have to insert new capabilities when the unit is operating near saturation and overload. It's already been doing reprioritization and sacrifice decisions. It's already reconfiguring activities and relationships. And now I have more of that to do. We can see that quote at the beginning as a challenge, right? Piles, load upon load, demand upon demand. And here's the overload paradox. Deploying resources to help, as resources mobilize, capabilities mobilize to be inserted, to deploy those capabilities takes load from the people over here who are overloaded or nearing saturation. So in order to get help to avoid being saturated, takes load. It takes load to get help because inserting the help, right, requires bringing them up to speed, coordinating them with other players, assigning them roles, right? Setting up communication strategies across those multiple roles, right? So deploying mobilized capabilities adds workload when the system is already overloaded and approaching very close to saturation. And that paradox is usually missed when people develop plans for handling abnormal and emergency situations. So notice now we're starting to have less patients, less burn patients. We are starting to move back to our normal range of surge capacity. What does that mean? We've coordinated with other groups. We've moved patients to other parts of the hospital or other medical facilities, right? The number of burn patients is decreasing. We've also been effective now, but notice the lag it took in order to get the patients who were already in the ER down. So we're starting to have moving from mid-40s to mid-20s in the non-burn patients in the emergency room. But think about how the extensibility continues to play out at this later stage. To some degree, we can go, hey, we're handling it, right? We've survived the worst of it, right? But there's a lot of work to move the load that's been imposed on this unit via coordination and synchronizations with other organizations, other units, even as the load is easing. So the load is easing, but the transition to moving people to other places is bringing other forms of load into play too that are often underestimated. This is happening in the context of a mess, right? Because in order to accommodate this, you had to have a ad hoc rearrangement, reconfiguration, reprioritization of what's going on. And so there are residual messes all over the place. And those get in the way, they have to be cleaned up, right? In a variety of senses of cleanup. It takes work. It doesn't just disappear by happenstance. It doesn't just call in the recovery staff and they'll take care of it and you can just come back in the next day. No, no, no. There is a lot of stuff to still do. Again, often missed how the denouement plays out, has load, consequences, mistake, things that can go wrong, right, that are often misunderstood in the way that we look at handling large surprises that challenge systems. We're reprioritizing, we're reconfiguring, and we're demobilizing. All effortful processes that still play out even though they're at the last part of a beyond surge capacity event, right? The last phase of a large episode of putting extensibility into action and how that plays out. So eventually the stress ends, right? We've returned to a typical expected pattern of load variations. What happens next? Wait a minute, we were under high stress. And the experience of high stress has multiple implications. The short term, there's a refractory period following an episode of high stress. A refractory period, lower performance, right? How do you take care of patients? Because there's still, upper 20s of patients in this emergency room. Patients will still be injured for other reasons and still come to emergency rooms. The staff, right, and the extended staff who came in need to perform. Yet there is exhaustion, right, from the high stress event in and of itself as a stress event, as well as the various things that went on. And so you can worry about lower periods of performance, being effective at your performance following a stress event. This is called a refractory period, and it's real, and it always exists, right? To some degree, there always is this refractory recovery period. Second is, what happened in this? Well, in some ways, everybody had to adapt. And in that process, you learn something about adapting. And the question is, does that have a long-term effect or only a short-term effect? Is it we got through that challenge, I don't have to worry about that again? Or is it, look how we adapt, our capability to adapt. Let's understand more about what's good about how to reprioritize and reconfigure. Right? These are called after-action reviews, where we go back through and try to understand, but we want to focus them on adaptive capacity. How did you reconfigure and reprioritize? All right, how did you stay anticipatory, right, as things were saturating and recruiting and mobilizing resources and capabilities before, right, you reached a brittleness point and collapse? In other words, you were anticipating instead of reacting. In these events, we were able to trace it out that even though it was very challenging and sometimes close, they were anticipating and replenishing in advance of saturation. They were staying ahead despite the challenges and not getting trapped in reacting. And the more you react, guess what? The more load goes up. The closer you are to saturation, the easier it is for more brittle mini collapses to happen where care, right, falls short of desirable and people's injuries are not treated adequately, right? So long-term consequences are worse than they might have been. Notice also that the ER already has experience with operating. Let's go back to the first point. at beyond its nominal surge capacity. In other words, it's already learned how to adapt to surges. And to some degree, that makes this a special example. Their experience with having to adapt their adaptive capacity makes them better able to handle one that goes well beyond the normal range of extra surge capacity they can bring to bear. Now, that's a limit on our ability to design and architect systems to have graceful extensibility. Does it require you to have to adapt a lot in order to do this? Or can we learn and architect systems who may only experience these large-scale surprises, right, in a way so that experience them rarely, they can perform as if they're well practiced at them. And that's a kind of fundamental that resilience engineering delivers on by helping you set up adaptive capacity potential, right? And we do that by focusing on the normal kind of adaptations to demands given the gaps, right? And that's where we started. This system doesn't operate at its nominal surge capacity. It regularly operates beyond its surge capacity. So how we respond near saturation, how we respond approaching saturation is a universal property that defines the resilient performance potential of real systems at all scales and in all sectors.